Hello everyone and welcome back to today's lecture on energy efficient buildings. My name is Mohammad Ehtisham and our focus today will be on our new module, Module 10. This is lecture number 32, Energy Auditing and Performance Management. Energy auditing and performance management are essential tools for organizations seeking to optimize their energy consumption and reduce cost by conducting comprehensive assessments of energy usage, identifying inefficiencies and implementing targeted conservation measures. Businesses can significantly improve their energy efficiency, minimize environmental impact, and enhance their overall sustainability performance. Previously, we have already discussed smart building technologies and explored the building control and automation systems and its implementation, energy efficiency, design consideration for different climates, and strategies for new buildings and existing buildings, along with building envelopes and insulation, effective lighting solutions, renewable energy integration. The outline of this lecture will be about auditing and management. We will be covering introduction to energy management, energy audit, types of energy audit methodology, energy conservation opportunities or ENCON, and lastly energy audit report. Moving on, let's start with what is energy management. Energy management is a systematic process of monitoring, controlling, and optimizing energy consumption within an organization. Its primary objectives include improving energy efficiency, reducing energy cost, minimizing environmental impact, and ensuring regulatory compliances. The goal of energy management focuses on minimizing cost and environmental impact through various strategies. Cost reduction is achieved by implementing energy efficient technologies and practices which can significantly lower utility expenses, increase profitability, and enhances competitiveness. Environmental sustainability is addressed by reducing a company's carbon footprint through energy saving measures and utilizing renewable energy sources, contributing to a more sustainable future and improving the company's reputation as an environmentally responsible entity. Integrating energy management into a company's strategy is essential for several reasons. It enhances operational efficiency by optimizing energy use, leading to better business performances and competitiveness. By incorporating energy management into the strategic plan, companies can align their operations with broader sustainability and corporate social responsibility goals, enhancing their brand image and stakeholder trust. Proactive energy management helps mitigate risk associated with energy supply disruption and price fluctuation, ensuring business continuity and stability. As government enforces stricter energy efficiency and environmental regulation, integrating energy management helps companies stay compliant and avoid potential penalties. Moreover, energy management fosters a culture of continuous improvement and encouraging regular assessment and enhancement of energy saving initiatives, which can lead to long-term benefits. So, what do you mean by energy audits? How are they defined and what are their importance and how are they relevant? An energy audit is a comprehensive evaluation of how energy is consumed within a building, process, or systems. It involves inspecting, surveying, and analyzing energy flow to identify potential areas for improvement in energy efficiency and conservation. The importance of energy audits lies in their ability to provide detailed insights into energy usage, highlight inefficiencies, and suggest actionable measures to reduce energy consumption, thereby supporting cost savings and environmental sustainability. Energy audits employ a systematic approach to decision making in energy management. This involves balancing total energy inputs with their usage and identifying all energy streams within a facility. The process includes data collection, site inspection, and detailed analysis, which help in quantifying energy usage and in identifying inefficiencies. This structured methodology supports informed decisions regarding energy conservation, measures, and investments. The audit process aims to balance energy inputs by understanding how energy is used across various different functions and systems. It identifies energy streams and quantifies their usage, providing a clear picture of energy distribution within a facility. This helps in pinpointing areas where energy is wasted and where improvements can be made to optimize the energy use. Energy audits are essential for organizations aiming to enhance energy efficiency and reduce operational cost. They help identify unnecessary energy expenses and provide a detailed report or the energy efficiency of a site. Conducting an energy audit is crucial for developing an energy conscious brand and ensuring compliance with energy efficiency standards. Energy audits have significant potential for cost reduction. By identifying inefficiencies and recommending energy saving measures, audits can lead to substantial savings on energy bills. Businesses that have not conducted an energy audit in several years may be spending 10 to 30% more for energy cost than what is necessary. Implementing audit recommendations can result in reduced energy expenses and improved operational efficiency. Energy audits play a crucial role in identifying areas for improvement and waste reduction. They uncover inefficiencies in energy consumption, such as outdated equipment or poor operational practices, and suggest improvements like upgrading to energy efficient technologies. The audit process also involves evaluating equipment efficiency and occupant behavior, providing insights into potential energy saving opportunities. By addressing these areas, organizations can enhance their energy performances and contribute to the sustainability goals. So, what are the type of energy audits? Energy audits are essential tools for assessing and improving energy efficiency in buildings and facilities. They can be categorized into different types based on their scope and depth of analysis. To start with, first is preliminary energy audit. A preliminary energy audit, also known as simple audit or walkthrough audit, is a basic assessment of energy usage. It involves a quick evaluation using existing data and is designed to identify immediate improvements and set baselines for further analysis. This audit relies on readily available data such as energy bills and basic facility information to estimate the energy consumption and identify obvious areas of inefficiencies. The primary goal is to pinpoint easy to implement long cost measures that can lead to immediate energy savings. It also establishes a baseline for energy consumption which can be used for comparison in more detailed audits. Second is targeted energy audits. Targeted energy audits focus on specific systems or areas within a facility such as lighting, HVAC systems or boilers. This type of audit is more detailed than the preliminary audit and provides focused insights. The audit zeroes in on particular system or components that are known or suspected to have inefficiencies. This allows for a more concentrated analysis of energy use within those systems. It provides a thorough evaluation of the targeted systems, offering specific recommendations for improvements and potential energy savings. This approach helps address particular concerns and optimize the performance of specific energy consuming systems. The next one is detailed energy audit. A detailed energy audit, also known as comprehensive audit, involves an in-depth analysis of all major equipment and systems within a facility. It is the most thorough type of energy audit. This audit includes a detailed examination of energy use across all systems and all the components, often employing advanced tools and techniques such as thermographic imaging or data logging. A key aspect of this audit is the energy balance, which assesses the interaction effects between different systems and their collective impact on energy consumption. The audit provides a comprehensive report with specific recommendations, cost-benefit analysis, and an implementation plan for energy saving measures. Each type of energy audit serves a specific purpose and provides varying tools of detail and insight, allowing organizations to choose the most appropriate approach based on their needs and objectives. Moving on, what is the methodology for energy audit? Energy audits are conducted through a structured methodology that involves several phases, each with specific activities and objectives. This methodology ensures a comprehensive assessment of energy usage and identifies opportunities for improvement. The whole methodology is divided into multiple phases. To start with, the first is pre-audit phase. The pre-audit phase is a crucial stage in the energy auditing process that focuses on planning and preparation to ensure a successful and comprehensive assessment of energy usage. This phase involves several key aspects. The first one is establishing the energy audit team. Our dedicated energy audit team is formed consisting of individuals with relevant expertise such as energy managers, engineers, and facility managers. The team is responsible for coordinating and executing the audit activities, ensuring effective communication and collaboration throughout the process. Next one is defining the scope and objectives. The scope of the energy audit is clearly defined, specifying the facilities, systems, and the processes to be included in the assessment. Objectives are set for the audit, which may include identifying energy saving opportunities, reducing energy cost, improving energy efficiency, and meeting the sustainability goals. Gathering preliminary data. Relevant data is collected prior to the on-site audit to gain a better understanding of the facility's energy consumption patterns. This data may include utility bills, facility drawings, equipment specification, production schedules, and any existing energy management plans. Next one is conducting a kickoff meeting. A kickoff meeting is held with key stakeholders, including the energy audit team, facility managers, and relevant personnel. The meeting serves to discuss the audit process, clarify expectation, and address any initial concerns or questions. It also provides an opportunity to gather additional information and insights from the facility staff. Next one is identifying the energy systems and equipments. The energy audit team identifies the major energy consuming system and equipments within the facility. This may include HVAC systems, lighting, production machinery, compressed air systems, and other significant energy users. Understanding the layout and operation of this system is essential for planning the audit activities. Following the development or developing an audit plan. Based on the gathered information and identified energy systems, an audit plan is developed. The plan outlines the specific activities to be conducted during the audit, including data collection methods, measurement points, and analysis techniques. It also assigns responsibilities to team members and ensures a timeline for the audit process. Arranging necessary resources. The energy audit team ensures that all necessary resources such as measurement equipment, data loggers, and safety gears are available and are in proper working condition. Any required permits or access permissions are obtained to facilitate the audit process. Next one is conducting preliminary assessments. Initial assessments may be carried out to gain a first-hand understanding of the facility's energy performance. This can include walkthrough audits, visual inspection, and preliminary measurements to identify obvious areas of energy waste or inefficiency. By thoroughly executing the pre-audit phase, the energy audit teams lay a solid foundation for a successful and comprehensive energy assessment. This phase ensures that the audit is well planned, focused, and equipped with the necessary resources and informations to identify opportunities for energy optimization and cost savings. The pre-audit phase set the stage for the subsequent audit phases, where detailed data collection, analysis, and identification of energy conservation measures take place. By investing time and effort in the pre-audit phase, organization can maximize the effectiveness and impact of their energy auditing efforts. Moving ahead, the next phase is audit phase. The audit phase is the core of the energy audit process, where a comprehensive assessment of the energy usage is conducted through detailed data gathering and analysis. This phase includes several key steps. First one, data gathering and process flow diagrams. The audit team collects detailed data on energy consumption, including historical utility bills, equipment specification, and operational schedules. Moving ahead, the next phase is audit phase. The audit phase is the core of the energy audit process, where a comprehensive assessment of energy usage is conducted through detailed data gathering and analysis. This phase involves several key steps. The first one is data gathering and process flow diagrams. The audit team collects detailed data on energy consumption, including historical utility bills and equipment specifications and operational schedules. They create process flow diagrams to visualize the energy flows within the facility and identify potential inefficiencies. This data forms the foundation for the subsequent analysis and identification of energy conservation opportunities. Second one is surveys, monitoring, and detailed trials. The audit team conducts surveys to gather information on energy usage patterns, operational practices, and occupant behavior. They use specialized tools and instruments such as power analyzers, data loggers, and infrared cameras to measure and monitor energy consumption in real time. Detailed trials and experiments are conducted to assess the performance of energy intensive equipment and systems under various operating conditions. This step helps identify areas of energy waste, inefficiencies, and potential for optimization. Next step is analysis of energy use and identification of conservation opportunities. The collected data is thoroughly analyzed to identify patterns, trends, and anomalies in energy consumption. The audit team examines the efficiency of various energy consuming systems such as HVAC, lighting, production processes, and building envelope. They compare the facility's energy performance against the industry benchmarks and best practices to identify areas for improvement. Based on the analysis, the team develops a list of energy conservation measures or ECMs that can be implemented to reduce the energy consumption and improve the efficiency. The next one is energy balance and interaction effects. The audit team develops an energy balance which accounts for all the energy inputs and outputs within the facility. They examine the interaction effects between different energy systems and how they impact overall energy consumption. This holistic approach helps identify synergies and opportunities for integrated energy management. Next one is feasibility analysis and prioritization of ECMs. The identified energy conservation measures are evaluated for their technical and economic feasibility. The audit team assess the potential energy savings, implementation cost, and payback periods for each ECM. They prioritize the ECMs based on factors such as cost effectiveness, ease of implementation, and alignment within the organization's goal and resources, followed by reporting and recommendations. The audit team compiles a comprehensive report summarizing their findings, analysis, and recommendations. The report includes a detailed description of the identified energy conservation opportunities, their potential savings, and the implementation strategies. The team presents the report to the organization stakeholders, explaining the benefits and implications of each recommendations. Throughout the audit phase, the audit team may also engage with facility personnel to gather additional insights, validate findings, and discuss potential implementation challenges. Regular communication and collaboration with stakeholders are essential to ensure the accuracy and relevance of the audit findings. The audit phase culminates in a set of actionable recommendations that form the basis for the post-audit phase, where the organization implements the identified energy conservation measures and monitors their effectiveness over time. By conducting a thorough and systematic audit phase, organizations can gain a deep and better understanding of their energy usage patterns, identifying areas for improvements, and develop a targeted strategies to optimize energy efficiency and reduce cost. The next phase is post-audit phase. The post-audit phase is a critical stage in energy auditing processes that focuses on implementing the recommendations identified during the audit phase and ensuring continuous improvement in energy efficiency. This phase involves several key steps. First one is presentation of audit findings and recommendation. The energy audit team presents the audit report to the organizational management and relevant stakeholders. They discuss the key findings, identified energy conservation measures, and their potential impact on energy efficiency and cost savings. The presentation provides an opportunity for stakeholders to ask questions, provide feedback, and gain a clear understanding of the audit results. The second one is development of an implementation plan. Based on these audit recommendations, an implementation plan is developed to outline the steps required to put the ECMs into action. The plan prioritizes the ECMs based on their feasibility, cost effectiveness, and alignment with the organization goals and resources. It assigns responsibilities, timelines, and resources needed for each ECM implementation. The implementation plan also considers any necessary approvals, budgeting, and coordination with other departments or external parties. Next one is implementation of energy conservation measures. The organization proceeds with the implementation, the prioritized ECMs according to the implementation plan. This may involve a range of activities such as upgrading equipment, optimizing processes, retrofitting systems, or changing the operational practices. The implementation process may require coordination with various departments, contractors, and suppliers to ensure smooth execution. Regular progress monitoring and reporting are essential to track the implementation status and address any challenges or delays. Fourth one is monitoring and verification of energy savings. After the ECMs are implemented, a monitoring and verification, or we say M&V process, is established to measure and validate the actual energy savings achieved. The M&V plan defines the methods, metrics, and baseline condition used to quantify the energy savings. Regular data collection and analysis are conducted to compare the post-implementation energy consumption with the baseline and calculate the realized savings. The M&V process helps demonstrate the effectiveness of the implemented ECM and provides valuable insights for future energy efficiency initiatives, followed by continuous improvement and ongoing monitoring. The post-audit phase emphasizes the importance of continuous improvement in energy management. The organization establishes a system for ongoing monitoring and analysis of energy performance to identify further opportunities for optimization. Regular energy audits or assessments may be scheduled to track the progress, identify new ECMs, and ensure the sustainability of energy efficiency efforts. The organization may also consider implementing an energy management system to systemize and integrate energy efficiency into its overall operations and decision-making process, followed by training and awareness. To ensure the long-term success of energy efficiency initiatives, the organization invests in training and awareness programs for employees and stakeholders. These programs aim to build energy literacy, promote energy efficient behaviors, and fosters a culture of energy conservation within the organization. Regular communication and engagement activities help maintain momentum and encourage continuous improvement in energy performance, which is followed by reporting and communication of results. The post-audit phase includes reporting and communicating the results of the implemented ECMs to stakeholders, including the management, employees, and external parties. Regular progress reports, case studies, and success stories are shared to highlight the achievements, benefits, and lessons learned from the energy efficiency initiatives. Transparent communication helps build support, motivate further action, and showcase the organization commitment to energy efficiency and sustainability. The post-audit phase is an ongoing process that extends beyond the initial implementation of ECMs. It requires sustained effort, commitment, and collaboration from all the levels of the organization to achieve long-term energy efficiency, improvement, and cost savings. Energy audit report. What is energy audit report? Energy audit report is a comprehensive document that summarizes the findings, analysis, and recommendation resulting from an energy audit. It serves as a valuable tool for organizations to understand their energy consumption patterns, identify areas for improvements, and make informed decisions regarding energy efficiency measures. Here the detailed explanation of the key components and structure of the energy audit report comprises of: to start with, executive summary. The executive summary provides a concise overview of the energy audit purpose, scope, and key findings. It highlights the most significant energy conservation opportunities identified, their potential savings, and the overall impact on energy efficiency and cost reduction. This summary is designed to give decision makers a quick understanding of the audit results without delving into technical details, which is followed by introduction and background. This section introduces the context and objectives of the energy audit. It provides background information about the organization, the facilities audited, and the reasons for conducting the audit. It may also include a brief description of the audit methodology and the team involved. The facility description and energy use profile was also discussed in a section discussing the physical characteristics and operational details of the audited facilities, which includes information about the building envelope, HVAC systems, lighting, equipment, and any other relevant energy consuming systems. The energy use profile presents a breakdown of energy consumption by source, that is electricity, natural gas, and end use like lighting, heating, and production processes. It may also include historical energy consumption data, energy intensity metrics, and benchmarking against similar facilities or energy standards. Energy conservation measures. The section forms the core of the energy audit report, detailing the identified energy conservation measures. Each ECM is described in detail, including its scope, implementation, requirements, and expected benefits. The report provides a technical analysis of each ECM, including calculations of energy savings, cost savings, and payback periods. It may also include information about the feasibility, priority, and any potential challenges or consideration associated with that each ECM. Financial analysis and investment plan presents the implications implementing the recommended ECMs. It includes a detailed cost-benefit analysis considering the initial investment cost, operating cost, and projected energy and cost savings over time. This investment plan prioritizes the ECM based on their financial viability and alignment with the organization budget and goals. It may include scenarios or options for phased implementation, financing strategies, and potential incentives or grants if available. Implementation roadmap and actionable plan provides a clear roadmap and action plan for implementing the recommended ECMs. It outlines the steps, timelines, and responsibilities for each ECM, considering dependencies and coordination requirement. The action plan may include guidance on project management, procurement, installation, commissioning, and training. It also addresses any necessary approvals, permits, or any regulatory compliances aspects. Measurement and verification (M&V) plan outlines the approach and methodology for measuring and verifying the actual energy savings achieved after implementing the ECMs. It defines the baseline condition, data collection methods, and performance metrics to be used for M&V. The M&V plan ensures transparency, accountability, and continuous improvement in energy efficiency efforts. Conclusion and what are the next steps? The conclusion summarizes the key findings and recommendation of the energy audit. It emphasizes the potential benefits both in terms of energy efficiency and cost savings that can be realized by implementing the recommended ECMs. It outlines the next steps for the organization, including security management approval, securing management approval, allocating resources, and initiating the implementation process. The conclusion may also highlight the importance of ongoing monitoring, reporting, and continuous improvement in energy management. Appendices and supporting documentation provides additional technical details, calculation, and supporting documentation referred and referenced in the main report. This may include detailed energy consumption data, equipment specification, measurement and verification protocols, and relevant industry standards or guidelines if any. The appendices serves as a valuable resource for technical staff and implementation teams to refer to during the ECM implementation process. The structure and content for an energy audit report may vary depending on the specific requirements, scope, and complexity of the audit. However, the above discussed components provide a comprehensive framework for presenting the findings, analysis, and recommendations in a clear and actionable manner. An effective energy audit report should be well organized, visually appealing, and easy to navigate. The use of executive summaries, clear headings, visual aids like graphs, chart, tables, and concise language helps convey the key messages and facilitate decision making. The energy audit reports serve as a roadmap for the organization to prioritize and implement energy efficiency measures, track the progress, and continuously improve its energy performance. It is a valuable tool for communicating the audit findings to stakeholders, securing buy-in and resources, and driving positive change in energy management practices. Moving ahead with energy conservation opportunities or ENCON. Energy conservation opportunities ENCON are initiatives aimed at reducing energy consumption and improving energy efficiency within various systems and processes. The opportunities are identified through energy audits and are critical for achieving cost saving and environmental benefits. Identifying ENCON opportunities involves a comprehensive assessment of current energy usage patterns and systems to pinpoint areas where energy efficiency can be improved. The process typically includes analyzing energy consumption, understanding how energy is currently used within a facility, including identifying major energy consuming equipment and processes, followed by benchmarking, comparing current energy performance against industry standards or historical data to identify the inefficiencies, evaluating the technological patterns or options, considering new technologies and practices that could enhance the energy efficiency. What could be the fuel substitution and energy regeneration? Fuel substitution involves replacing existing energy resources with more efficient and environmentally friendly alternatives. This can include switching to renewable resources energy, utilizing solar, wind, or biomass energy to replace fossil fuels, adopting cleaner fuels, transitioning from coal or oil to natural gas and electricity, especially when sourced from renewable energy. Energy generation opportunities also include implementing on-site renewable energy systems such as solar panels or wind turbines to reduce reliance on external energy resources. Improving efficiency in energy distribution and process can lead to significant energy savings, which include optimizing the distribution system, enhancing the efficiency of electrical, steam, or compressed air distribution system to minimize the losses. Process optimization, streamlining industrial processes to reduce energy consumption, such as upgrading equipment or implementing advanced control system. Assessing the technical and economic feasibility of ENCON measures is crucial for their successful implementation, which involves the technical feasibility and economic viability. Evaluating the availability, reliability, and compatibility of new technologies within the existing systems refers to the technical feasibility. Conducting cost-benefit analysis to determine the financial return on investment using methods such as payback period, internal rate of return, or net present value refers to economic viability. What are the classifications of ENCON measures? They are classified as low, medium, or high cost. ENCON measures can be classified on their cost and potential return on investment. Low cost, high return measures that require minimal investment but offer significant energy savings, such as optimizing existing systems or implementing simple operational changes. Medium cost, medium return measures that involve moderate investment and provide reasonable savings, such as retrofitting equipment or upgrading control systems. High cost and high return measures that require substantial investment but have the potential for large saving, such as installing new energy efficient technologies or major process changes. Prioritizing these measures often involves considering the ease of implementation, potential impact on energy savings, and alignment with the organizational goals. Low-cost measures typically receive priority due to their quick payback and ease of implementation, while high-cost measures may require more careful planning and phased implementation. So what does we conclude? Energy management and energy audits are essential components of a comprehensive strategy for optimizing energy consumption, reducing cost, and promoting environmental sustainability within the organization. By integrating energy management into company strategy and conducting thorough energy audits, businesses can identify opportunities for improvement, implement targeted energy conservation measures, and achieve significant financial and environmental benefits. The systematic approach to energy management involves setting clear objectives, monitoring energy usage, and continuously seeking ways to enhance efficiency. Energy audits, which can be preliminary, targeted, or detailed, provide valuable insights into energy consumption patterns and help identify areas for improvement. The energy audit methodology, consisting of pre-audit, audit, and post-audit phases, ensure a structured and effective assessment of energy usage. Identifying ENCON is a crucial aspect of the audit process. These opportunities can range from fuel substitution and energy generation to efficiency improvements in distribution and process. Assessing the technical and economic feasibility for prioritizing and implementing the most impactful and cost-effective solution. The audit report serves as a comprehensive document, summarizes the finding, recommendation, and potential benefits of the audit. It provides management with a clear understanding of the energy performances and guides implementation of the energy saving measures. The report structures and content include the summary, analysis of consumption and efficiency, the prioritized recommendations, facilitate informed decision making, and drive continuous improvement in energy management. By embracing energy management and conducting regular energy audits, organizations can unlock significant cost savings, enhance operational efficiency, and demonstrate their commitment to environmental sustainability. As global energy demands continue to rise and the need for sustainable practices become increasingly pressing, the adoption of effective energy management strategies and implementation of energy conservation measures will be a boon. Thank you. We'll continue with the next lecture.